Hello everyone. In this video I am going to demonstrate power line communication using FSK modulation technique on 220 volts AC mains line. As you can see, this is my circuit. So my circuit consists of basically two parts. This is the transmitter unit and this is the receiver unit. As you can see on the transmitter unit, Arduino Uno is sending data. I am sending alphabet M constantly from this Arduino unit, and it is fed to this modulator unit. The modulator unit is modulating the data and it is feeding to this transformer. So let us briefly discuss the transmitter unit. So the Arduino Uno data alphabet M is fed here. You can see the LED is flashing. So this LED is getting the data and the data is fed to this optical isolator. The optical isolator output is fed to this transistor and 555 timer IC. This is the modulator unit. So the modulator unit is basically generating two different frequencies, F1 and F2. Based on the logic state 0, it is generating two different frequencies. The output of this modulator unit is fed to this power MOSFET. This modulator unit has been described in my previous videos. Please watch my previous videos for the good explanation of this modulator unit. The output of this 555 timer IC is fed to this power MOSFET. The power MOSFET is driving this coupling transformer. This is the transmitter end coupling transformer. So this transformer basically couples the transmitter with the power line. And you can see here there is power line input at this point. You can see I am feeding the power line at this point. Here you can see these are the two wires for the power line. So transmitter coupling transformer is in series with the power line and the receiver coupling transformer. You can see the receiver coupling transformer. This is the receiver coupling transformer. So the data from the transmitter coupling transformer is received by the receiver coupling transformer and finally it is fed to this receiver unit. You can see this is the receiver unit. So here you can see this is the 220 volts AC mains line input, this brown wire and the red wire. You can see. So this brown wire and the red wire is fed to this lamp. You can see here it is fed to this lamp. You can see, and you can see here this is connected to this power line. Now this is the variac I am using. I am going to control the AC line's mains voltage slowly and I am going to see the response of this circuit. Directly I will not give 220 volts AC mains supply. So now here you can see this is the receiver unit. So once the data is received by the receiver coupling transformer, it is fed to this demodulator. You can see this is a Schottky rectifier. Here is a capacitor and here there are two resistances. So this is a demodulator. The output of this demodulator is fed to this comparator. You can see here this comparator compares the output of the demodulator with the reference voltage. So this reference voltage we need to set for proper data reception. The output of this first comparator is inverted. I am sorry, it is not optically inverted, it is just inverted. The inverted data is again fed to another comparator here and it is rectified. Finally, the correct data is fed to Arduino Uno. I am going to explain this comparator block very clearly in the circuit diagram. It will be very clear. This comparator is IC-LM339. So the final received data at the Arduino Uno is fed to the computer console. So here I am transmitting alphabet M and at this end alphabet and at this Arduino Uno, at this Arduino Uno also I should be receiving alphabet M. So before showing the results, I am going to show you the circuit diagram with all the voltage levels at different points. So as you can see here, this is the circuit diagram. You can see this is Arduino Uno, transmitter Arduino Uno. It is feeding data at this point, optically isolated with optical isolator MCT2E, and here is the voltage 12 volts DC. This is the transmitter end voltage. Since the voltage here is 12 volts DC, I am using optical isolator so that the FSK signal of the transmitter unit is isolated from the Arduino Uno. So the transmitted data is fed here optically isolated and it is fed to this 555 timer IC. So here it is generating the FSK data. Please watch my other FSK videos where I have explained the data generation of this block. So output of this 555 timer IC is FSK modulated data, and it is fed to this MOSFET IRF 840. This MOSFET is driving the transmitter coupling transformer. This is the transmitter and coupling transformer. So the output of this transformer is fed to this power line. You can see 220 volts is fed here. You can see here. So since the number of winding is very less, there will be no voltage drop, very less voltage drop. So I am going to keep all the windings in series with the 220 volts line. So you can see here, this is the receiver winding, and the output of the receiver winding is fed to this demodulator envelope detector. You can see this is the rectifier, and here you can see capacitor and the 2 to 10K resistances. I am going to show you something important here. You can see I am using 3 different windings in the transmitter coupling transformer. So I am using 10 to 12 turns on each windings, and you can see on this spare winding I am measuring 19 volts AC to 16 volts AC. So this is the voltage on this spare winding. You can see this voltage will oscillate with the data, and you can see this when this voltage and the data, everything is coming to the receiver coupling transformer. Here you can see on this winding here the voltage will be 16 to 18 volts. It will vary with the data, and the output of this transformer here at this point, the voltage has to be 3.9 volts to 2.8 volts AC. You can see 3.9 to 2.8 volts AC. Here 16 to 18 volts AC. Here 3.19 to 2.8 volts AC. This voltage is very important, because if this voltage is higher than 5 volts or nearly equal to 5 volts, this might damage this comparator. I have experienced this before. So please ensure this voltage is quite lower. So somewhere near 3.5 volts is better. So as you can see, the output of this demodulator is fed to this first comparator, and you can see here this voltage at this reference voltage setting I am using 157 volts DC. You can see the comparator, it is comparing against 2 voltages. So the voltage at pin number 9 has to be 1.157 volts DC. You can see. So this voltage must be adjusted to 1.157 volts DC or somewhere nearby this value. So you can see here this voltage is arriving here, and it is getting compared with this voltage here, and this output here will be inverted. So again I am using this comparator to rectify the voltage polarity, and finally the output is fed to the receiver Arduino Uno. You can see it is fed to the receiver Arduino Uno. So this is how the circuit diagram works. So remember, the voltage at this point should be 3.19 to 2.8 volts AC. You can see here, and the voltage at this point has to be 1.157 volts DC. So these 2 points are very important for the correct data reception. So now let us look into the data console first. Currently you can see the lamp is off, and I am going to show you the data console with the received data. As you can see on the receiver data console, I am receiving alphabet M. Continuously I am receiving alphabet M. You can see. Let us look into the oscilloscope waveform. So this is the waveform I am receiving. You can see the yellow waveform is the final data waveform, real data waveform. You can see here, this is the data I am receiving, waveform data I am receiving. So now I am going to switch on the AC mains line, and we will be observing the oscilloscope. We will be observing the oscilloscope data. The AC mains line is already on. So now I am going to increase the voltage. Let us see the voltage here. You can see the waveform, what's happening to the waveform when I am increasing the voltage. But the received data is okay. You can see. So this video is little big. You can see the lamp glowing also here. So let us see now. The lamp is glowing full. You can see the data is not corrupted. The top pen is the received data. You can see there is a mixed signal. You can see. So now let us look into the data console. You can see on the data console I am receiving alphabet M continuously. Here you can see the lamp is on, 220 volts. The variac is at its full value. You can see data reception is okay. Alphabet M is being received. And here you can see the waveforms. The top waveform is the data waveform. So this is how we can transmit data over power line using FSK modulation technique. This is the overall view of the project. You can see data transfer is in progress. Thanks a lot. Thanks for watching.